Hello everyone. Before we talk about blood spatter, we're going to talk a little bit about surface tension. It is this property that determines what shape blood takes as it flies through the air, and thus a little bit about how it splatters when it hits a surface. Surface tension is something called a cohesive force. And what that means is the molecules within the blood or within other liquid substances actually stick together because they're polar. You often hear this in association with water and surface tension. So what's happening here? So let's think about this with water. You have a water molecule here, and water is something called polar, which means it has a slight positive and negative charge to it. So if you get a whole bunch of these water molecules together, they will stick to each other, just like magnets, which have positive and negative ends, will all stick together. So you have these water molecules, right, all sticking together because of these charges, and they hold on to each other pretty tightly. And so tightly they create some resistance when something is on its surface. Now, what does this mean for blood? Right, surface tension, so the molecules within the blood sticking to each other, allow blood droplets to be spherical when they fly through the air. So for example, if you take a look at a blood droplet here, it's almost a perfect sphere. Now, when that sphere strikes the surface, something interesting is going to happen. Right? The blood is actually going to be pushed outwards, creating a rim on that blood droplet. So if we take a look at some time-lapse photography here, we can see, right, the blood droplet drops straight down, okay, and we can see this rim forming, right, from the blood droplet due to the spherical shape. Now, depending on the surface that it strikes, this could cause it to look a bit different. Now, if the surface is smooth, you're going to get blood droplets that are nice and round and spherical. There's nothing really to interrupt the rim as it goes outwards. However, if the surface is rough, right, then that rim is broken, right, by the surface, and you get these small splatters. And these little small, tiny blood droplets are called satellite stains. You can also get spines coming off of it. Okay, I would like you to draw this if I didn't have it in your notes already. Now, if the blood was not dropped directly down, but rather was traveling through the air, this is something called wave cast-off, and it can help us determine the direction that the blood was traveling in. Okay, so we have our blood droplet. It's coming in at an angle. When it strikes the surface, that blood still has some inertia, so if you remember your physics. And some of that blood is actually going to be cast off, like a wave crashing onto shore, and you'll get these little blood droplets that come off of the parent drop, and they go in a certain direction. Okay, so if this was our parent drop, we have these little tiny blood droplets come off of that, and that actually tells us what direction that blood was traveling in. So if you take a look at some blood spatter here, this was some blood squirted from a syringe from a height of 1 meter. Right? Let's see if you can figure out what direction this blood was traveling in. Was it traveling to the left, or was it traveling to the right, according to this picture? All right, well, let's take a look. So we're going to focus on this blood stain here just because it's nice and big. Right, so we have a big section of blood right here. So that's probably the parent drop. And we have a little tiny blood spatter coming off of that. So one of those tiny droplets. So that meant that the blood was traveling in this direction to the right when it was ejected from the syringe. Now, this idea of determining direction is important. If you have blood spatter in the room, then you can determine where that spatter originated from based on the direction of the blood droplets. And this is called the point of convergence. Okay, so it's where the blood originated from. So for example, if you have some blood droplets, the first thing you want to do is to determine the direction that the blood was traveling in. Okay, so if you have some blood stains here, you would see little droplets, coming off of that. So what you want to do for the blood spatter, if you isolate a drop, determine what direction it is by using those tiny blood spatter stains. So this blood stain was traveling in this direction. This droplet of blood was traveling in this direction. And what you can do is you can extrapolate back from that. So if we draw an opposite arrow from those blood stains, you find that they meet at a certain point, and this point is called the point of convergence. Okay, so if you had blood spatter, on a floor, for example, all right, you could tell, where exactly the blood spatter originated from, on that floor based on the direction. Right, we can also work in 3 dimensions for this. So once we find the point of convergence, we can determine the origin of the blood within the room. Okay, and we're going to use the point of convergence and the distance above or away from that point of convergence. Okay, so for example, we have these blood droplets down here. Okay, and we determined the direction, and we found that the point of convergence, okay, was here. Right, then what you can do is you can find the angle of the blood, which you did in Lab 4, and you can determine where in space the blood originated from. So that's what you're going to do in Lab number 6. So if you would find the angle, and you can do this mathematically, or you can use the strings, and you can actually put strings from those blood droplets, and you find out the origin. Okay, so you find both 3 dimensions, so where 2-dimensionally the blood originated from, and 3-dimensionally what height it was.